Welcome to Click for Biology. Here we're looking at the eye and the process known as accommodation, which is actually how we focus images onto our fovea and macula. To understand this process, we need to change the angle at which we're looking at the eye. So previously we've been looking at the eye from front to back and naming the structures that way. But you'll recall that in this area here, we have the ciliary muscles. We have the lens, which is clearly indicated in this diagram here. And here we have the suspensory ligaments. And okay, so the ciliary muscles are here like so. And so we're looking at effectively as if we're looking from the front of the eye. The ciliary muscles go around the outside like so. And like all muscles, they have the capacity to contract. And when they contract, they get shorter. And if they contract, they get shorter, then the diameter of the ciliary muscle shown here in purple will get smaller. So the diameter gets smaller. And it's this effect which explains the focusing mechanism of the eye. And we'll go through this kind of slowly to help you with that. The lens is attached to the ciliary muscle by suspensory ligaments, which I'm just going over here again in blue. These suspensory ligaments are like pieces of string, and they cannot contract. So the lens is suspended from the suspensory ligaments from the ciliary muscle. And if we go back to cross-section again, then we could look at it like so. There's the ciliary muscle, and we remember that's a circle with suspensory ligaments going all the way around, and here's the lens like so. So let's look at the focusing mechanism knowing this idea. So we're going to begin by thinking about focusing on an object which is close. And so what better than a piece of writing? And indeed, you'll be doing this right now. As you view this video on your device, you will be using this type of focusing mechanism. Now, to focus light from a close object, we have to appreciate that light rays from that object are diverging away from their source. And it's necessary for the lens to bend them back and bring them to focus on the fovea, but that will require a large angle of bending. And to achieve that, the lens has to be this rounder, thicker shape. That will achieve the larger angles of bending the light rays to bring them into focus. Now, to achieve that, what we have to do is we have to contract the ciliary muscles. So these muscles here will contract, which means that the suspensory ligaments will become slack. Now, this is a difficult point to understand, so I'm just going to quickly draw not very well actually, the ciliary muscles here. And if they contract, then remember that their diameter will become smaller, and so the suspensory ligaments will no longer be pulled. Now, that being the case, as we go from here to here, the suspensory ligaments have gone slack. Under that condition, what happens is that this lens, we would say it recoils to its unstretched state, to this round state. In fact, the ability of the lens to return to its original round and thicker shape often declines later in life, so that as a person ages, the elasticity, the stretchiness of the lens is lost, and it no longer returns to this rounded shape. And as a consequence of that, some people then require to wear spectacles in order to assist the lens in still getting the focus onto the fovea. Let's take a look at when we look at a distant object. Now, for a distant object, the rays of light coming from this distant object are much more parallel, and the degree of bend required to bring it to focus onto the fovea is considerably less, and so therefore we need a thin lens. Now, in order to get the thin lens, what we need to do is we need to effectively pull the lens in this direction here, and that pulling effect is created by the suspensory ligaments. Now, to achieve that, we need the ciliary muscle to go from a narrow diameter. So I'm now talking about these muscles here forming a circle, and we want the circle to become larger, like so. And as it goes out like so, it will then pull on the suspensory ligaments, which in turn pull upon the lens, which in turn makes the lens thin, and that allows us to focus the light onto the fovea at the back of the eye and retina. And this is what's used for distant objects. So in the eye, if you're actually reading, you'll be contracting your ciliary muscles, and this is what leads to fatigue around the eye when one has been reading and studying for a long time. Which reminds me that the video is now 7 minutes long, so that's enough studying of the eye. And so now you can click the next link to go on and look at the topic of thermoregulation, the regulation of body temperature. And if you haven't done so already, please give us a subscribe. It's always very encouraging if you do that. Thank you.